Welcome to our section on potassium. This is going to be short because I'm just going to focus on fluid balance to explain an important concept. We're going to start with talking about sodium and potassium combined. So potassium, as you can see by the blue dots here, is our main inside intracellular cation. Cation means positively charged. Sodium, which is the purple, you can see the purple dots here, so there's more purple here. So that is the main extracellular cation, so extra outside of the cell, extracellular, and cation is positively charged. So these are the positively charged ions. These are electrolytes. And I'm just going to explain a little bit how they both work together to maintain fluid balance. And this is a very simplistic view. We already talked about chloride being an anion. That's an electrolyte. We have calcium and magnesium. I mean, there are other electrolytes that are within these intracellular, extracellular, and within the bloodstream. So this is just a simplistic view, so keep that in mind. Now, we look at the bloodstream, we can see both sodium and potassium in there, a little bit more in balance. So what happens if we eat a high amount of sodium? Now, sodium is represented by the purple dots, lots of sodium in here. Well, sodium is going to diffuse out and also be outside of the cell. So high amount of sodium outside the cell in relationship to potassium, and then high amount of sodium inside the bloodstream in relationship to potassium. Well, water is drawn to sodium, and it can just diffuse out. So water is going to be pulled out of the cell because the body is always aiming to achieve this equilibrium or this homeostasis. So what happens to that? Well, you have the cell that's normally large is going to be shrinking. Now, when the cell shrinks, this can cause some damage to the DNA or some of the structures of the proteins. Now, what I'm not showing here is that the kidneys are going to kick into high gear to try and get back the balance. And then there's also an adaptation, a cellular adaptation. So I'm showing a little bit more of an extreme view. However, in that process of, re-regulating, and getting back to a fluid balance, there can be some structural damage in the process on a very tiny, tiny level. But what is actually more commonly known is the influence of sodium on blood pressure. So as the fluid comes out, the cells shrink, and now we have more water here. We're also going to get more water in the bloodstream. When you have more water in the bloodstream, and this is to try and maintain that balance, we have more electrolytes, so now we need more water because we want an equal balance of water and electrolytes. It's like having this tube, and there's only so much room for so much water. So if you're putting more water in there, it's going to increase the pressure on there, right? So it's increasing the pressure in the bloodstream, increasing blood pressure. Again, we have systems in place. The kidneys are going to kick into high gear to get that regulated. But over time, you can see how that might contribute to blood pressure rising. Big caveat here. A lot of the newer studies are showing that high sodium intakes are not really the sole cause of rising blood pressure. Why? This is where we talk about potassium. Because it's not just sodium, it's the balance of sodium to potassium. So if you think about it, we have potassium here in blue. If we have less potassium, the ratio of sodium potassium all of a sudden changes. It's almost like you've increased your sodium. So you have the same effect by decreasing potassium. So it's the balance between the potassium and sodium, it's that ratio. So when we're not eating enough potassium, we're going to have the same effect. You can have that cell shrinkage, and then the cell will have to adapt. You're going to have the increase of blood pressure. The kidneys are going to have to kick in to adapt. So the high sodium and low potassium, those things are both of those things are going to create the same issue. Now, what do most Americans eat? I think we already know that. We know that we have a high amount of sodium and a low amount of potassium. What do we want to see? We want to see an increase in potassium in relationship to sodium. So what do we need to do? Well, potassium, no surprise, occurs in fresh, whole foods, fruits and vegetables, but also legumes and nuts, whereas sodium is really high in processed foods and fast foods. And as we've talked about all semester, we know that most Americans are eating too many fast foods and processed foods, too little whole, fresh fruits, vegetables, legumes, nuts, meat. So, salmon, avocado, plums, bananas, baked potatoes, lima beans, actually a lot of different types of beans, acorn squash. What's not on here is, dark leafy greens. So these are the foods that we need to eat to increase our potassium. All right, well, that's it for the section on potassium.